So this is this part down here. This is the actual box and whisker plot. This is a very busy looking screen. I have a lot of information on here. So let's just take a look at what it is. So these are football player weights. So how much a team of football player weighs. And this is just player 1, player 2, player 3, player 4. So really, once you know that, you can ignore this line up here. These are their actual weights in pounds. And notice that I have put them in order, because one of the key things that you have to do in a box and whisker plot is put your data in order from least to greatest. So we have 170, 184, 200 pounds, 210, and so on, all the way up to 320. And then you just find 5 basic numbers. These are the 5 things you're looking for. You're looking for the minimum, which of course is the least number in your data set, whatever you're measuring. And I always like to do it, I do it in this order. I think of it, I find the minimum and then I find the maximum. Those are very simple to find, the least and the greatest. Then I need to find the median, which is a measure of central tendency in your data. It means where things line up, where is about the middle. And there are a number of ways of calculating the middle. The median is one, the mean is one. We talk about the mean as being the average where you add up all the numbers and divide by the number of numbers, but the median is a lot more simple to find. All you need to do is find the number that's exactly in the middle of your data. So if there are 11 pieces of data in my data set here, I go to the middle piece. So player number 6 right here, this 6 value is the median. Just to make sure, I can see that I have 1, 2, 3, 4, 5 players on that side and 1, 2, 3, 4, 5 players on this side. So player number 6 is my median. So that is the median of my data set. And then I am going to divide my data in half, and I am going to find the median of the lower half. I ignore this median and I look at the other numbers there. I have 1, 2, 3, 4, 5 other pieces of data. Again, I'm looking for the middle value, and that's it right here. So I'm finding the median of the lower half of my data. So this is we call this the lower quartile. If you think of it, that makes sense, because if this shows me where half of my data is less than that and half of my data is greater than that, then dividing that half in half gives me a quarter. So this is the quartile. 25% of the numbers are below this number. 25% are between the quartile and the median. 25% are between the median and the upper quartile. 25% are between the upper quartile and the maximum. And I find the upper quartile the same way I found the lower quartile. I divide my data in half. I look at the upper half and I find the median. And that's this number right here. So one thing that box plots are really good for is noticing the spread of my data and seeing how far apart it is or how grouped together it is. And it's very visual and easy to see right away. And the next problem that we're going to do actually is going to show you how easy it is to make comparisons between data sets. And when I say data set, I mean all the data that I'm looking at in this one group. So if I wanted to compare the football players' weights between the Browns and the Broncos, I could have, this would be one data set for the Browns, that would be one data set for the Broncos. So here's another data set, and this looks like a lot of numbers, but we're not going to read through all those, so just hang on. The problem itself is pretty straightforward. So Ms. Bridges tests her kindergarten students on knowledge of letters monthly. So every month she's testing them how many letters do they know, because that's a key concept for kindergarten. So the test results for August, October, and December are shown below. So notice it's when they first start school, then halfway through that first semester, and then the end of the semester. So we have a couple kids who know all 26 letters. We have some that know no letters at all. And we have some that know quite a few, and then everything in between. So by October, we notice there are no zeros there, and a couple more who know all of them. And then by December, look at all these in the upper ranges of the 20s. So there are a lot of people, no zeros. Looks like 6 is the smallest. But that's all we can say looking at this quickly. When the first thing you need to do for a box and whisker plot is to put the values in order from least to greatest. And already this is so much easier to read and understand what's going on. Very clearly we see that we had 3 children that did not know any letters. Here we have 2 that know 3. Here we have 2 that know 6, and that's our least. So already we can see some differences between these. We see 2 26s, lots of 26s, even more 25s and 26s. So that's really cool. But how do we make a box and whisker plot from this? What can we say about this data? The first thing you do is find the minimum, the maximum, and the median of the data set. So the minimum, the least number, right there. The maximum, which is the greatest number. See, that's so easy to find. That hardly takes any thought. And now we have to look for the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 numbers. So that means the 7th number should be the middle. 1, 2, 3, 4, 5, 6, 7. And just to check, 1, 2, 3, 4, 5, 6, good. That's the median right there. So we can say our minimum is 0, our maximum is 26, our median is 8. Alicia, you with me so far?
Yes, I'm here. Yes,
Okay.
I'm trying to understand it.
Do you have any questions?
No problem. Okay.
Okay.
Yes. I understand. Okay, so you have to put them in order from smallest to biggest, and then you have to plot the ends, which is a greater number than a smaller number, and then okay. Do you do a median? Like when you do the median, is it like when you do the median, do you do more than one median, or is it just one median?
One. Well, first, to start, we're doing one median here for the whole data set. Okay. Then we're going to flip to the next one because this is the 5-number summary, and we've only got 3 numbers here. Okay. So to start, you just do the median of the entire data set. Then the next thing you do is find the lower quartile and the upper quartile, and that's the medians of the lower and upper halves of the data set. Okay, so this is where we divide our data set in half. There's our median. And now we look just at these numbers right here, and we find the median this half of the data.
Okay, I think that was my question. I think okay, when you do, so you do the median in the middle, which is, and then the other, and then both sides you have to do the median on each side.
Yep, that's
Okay.
exactly. There's the upper quartile, and that goes there for that median. That was a little bit goofy, but okay, you know what I meant. All right, so good. So here's the interesting thing. Before, when we were working on our problems, it just so happened that we had all odd numbers. So it's easy to find the middle of an odd number because it's on its own. Let me get back to what I need. Okay. But here we have an even number. So we're looking for, because we have 1, 2, 3, 4, 5, 6, there isn't a number right in the middle. So we have to add these two numbers and divide by 2. It's like finding the average of these two numbers. So we're going to find what number is exactly between 0 and 3. So to do that, we say 0 plus 3, divide by 2, and the answer is, get out of the way, little thing down there. The lower quartile is 1.5, because 1.5 is exactly in the middle between 0 and 3. So even though 1.5 is not in our data set, it marks the lower quartile.
So that's does that make it the median of the lower quartile?
Yes, indeed. That makes it the median of the lower half of this set, and that means it is the lower quartile. It has the number, the name of that number, 1.5, is the lower quartile. Okay? So hang on to this for a minute, and I'm going to show you what that looks like on the box and whisker plot. Okay? So then the upper quartile has the same thing, 1, 2, 3, 4, 5, 6 numbers, and no number right here where we need it in the middle. But look at this. These two are both 18. We can still add them together, 18 plus 18, divide by 2, but really, what's between 18 and 18? It's 18. So the upper quartile is 18. If you have the same number, then you call that the median. Does that make sense?
Could you say that one more time?
So because these two are the exact same number, then
okay,
a number in between them. So we can add them together and divide by 2, but we know that's going to give us 18. So either way, if you forget that the median should be 18, if you add it together and divide by 2, okay.
Okay.
So let's see what that looks like. We're going to get a chance to do that again. Oh, let me get rid of that. Okay. So now we're going to plot this 5-number summary, and the 5-number summary is the minimum, the maximum, the median, the lower quartile, and the upper quartile. So let's plot that on a number line. Remember, we said our minimum was 0, and our maximum was 26. Okay, so far so good, right? Then we put in our median, which was 8. And then the lower quartile, which is 1.5. And the upper quartile, which was 18. Whew, I almost forgot. 18. Okay, so that's how we mark it. Notice that because I've got this number line that has that jumps by fives, I'm doing a little bit of an approximation. 18, okay, because this would be 15, 16, 17, 18, 19, 20, you know, I'm trying to get close to the place. All right, so that's what you do. You mark the ends, the minimum and the maximum with a dot. You mark the lower quartile, the median, and the upper quartile with a line. And here's why, because the next thing you do is complete the box and the whiskers. You add a top to the box, you add a bottom to the box, you add a left whisker, and you add a right whisker. I have questions about that so far.
No.
Okay, good. So this looks like, as we're looking at this, what this tells me is for these kindergarten students, I can see here are the ones that don't know any letters. And then here's the lower quartile. So 25% of my students are coming in between 0 and 1.5. And 25% are between 1.5 and 8. So see, this means that there's a lot of students clumped down here. And see how spread out this is up here? Here's my median, and then look how long it is to get to the quartile. And look how long it is this whisker out here. So that means I have the exact same number of numbers from here to here and from here to here. But these are more spread out. So I've got more spread here, and I've got more students clumped down here in the lower numbers. I mean, they only know 8 numbers or left. Half of the kids know 8 numbers, not numbers, 8 letters or less. Half of the kids know 8 letters or more. So that's, you know, that's where kids should be in kindergarten in the first month. That's, you know, that's not bad. That's just telling me what my data is. Tells me that my kids are pretty normal. Let's look at the next group. Oh, yeah. So here's a key term, and symmetric. Symmetric means that it's pretty similar from side to side. So if you think about that if this median was in the middle of my data, right about here on 13, which is half of 26, then I would say my data is symmetric. And if my whiskers are pretty even, I would say my data is symmetric. But because this whisker is a little bit longer, and because the median is, you know, not in the middle, I would say that my data is skewed. And skewed means it's shifted in some way. It's not evenly distributed. So I always have a little bit of trouble thinking about which direction is it skewed. The way it's skewed is in the direction of the tail. Let me go back and let you look at this. See how this whisker is longer? It says if the median is located to the left of the center, and remember we said that this would be the center because if we were evenly distributed, the middle of our data would be 13. And so our median is located to the left of the center of the box. So the distribution is positively skewed. And that means you can think of it as being pulled in this direction. It's skewed towards the positive end of the number line, even though we don't have any negative numbers here. We call this positively skewed. If my median was over here, we would say it's negatively skewed. So we're going to get some practice with that. Don't worry about remembering exactly which way, but I do want to show you this to help you remember it. At least this helps me. The data is skewed in the direction it is being pulled. So imagine a ball of string with a long tail to one side. Most of the data is bunched up over here, but I've got a few numbers that are stretched out way over here. That means I am pulling it or skewing my data in this direction. On this one, if this side of the box is longer and more spread out, then I'm skewing it in this direction. I'm pulling it out here. Most of my data is bunched up here with this ball. But when I skew it left or skew it negatively, it's because I'm pulling and stretching the data out in this direction. So I had to have a visual to help me remember that because I don't want to describe how I could get confused with that, but I only want to leave you with the right way to think about it. So this is the right way to think about it, okay? If my data is being spread out and pulled in this direction, then I'm saying it's skewed this direction. Okay, now, so we're back to Mrs. Bridges and her kindergartners. And here's the data from October. So the first thing we do is we put our data in order from least to greatest. Notice least down here, and yes, it seems to go, yes, it goes all the way up in order to the greatest. And then the second thing we do is find the first three values of our 5-number summary. We have a minimum, a maximum, and the median. Okay, so our minimum is 3, our maximum is 26, our median is 21. Now this is an interesting data set because we have a maximum. It can't go on forever. So what we're expecting is that eventually our data will all clump down there towards the towards that maximum number of 26. There are only 26 capital letters that you can know. Okay. The next thing we're going to do is find the lower quartile and the upper quartile, which are the medians of the lower and upper halves of our data set. So we're going to divide our data in half. There's our median. And now we're going to look at these data. Notice I have more students in October than I had in August. And as you know, there are always some, maybe you don't know, but there are always some stragglers who come in, or maybe people who move and don't get there right at the beginning of school time. So we usually, especially in kindergarten, we seem to pick up students as the year goes by. So by October, all of these students now know at least 3 letters. And let's see, what is our lower quartile? 1, 2, 3, 4, 5, 6, 7, 8. We've got an even number again. So we're going to have to find the median by doing an average. So 7 plus 9 is 16. Divide by 2. That means our lower quartile is 8. Well, that makes sense because 8 is exactly in the middle of 7 and 9. And then over here, 1, 2, 3, 4, 5, 6, 7, 8. What's in the middle? 1, 2, 3, 4. Oh, we have another situation where we have 26 and 26. So we don't actually have to calculate that average. We know that it is 26. So there's our upper and lower quartile. How is that, Talisha?
It doesn't make it much better, but it could
Oh,
be worse.
I get it a little. I get it. I get it a little bit. It's a lot. It's a little confusing. It's not like the typical math, you know.
No, it's not. There's very little arithmetic in here. This is all data.
Wow.
Okay. So the next thing we need to do is plot that 5-number summary on a number line. And remember, what was our minimum? It was 3. Our maximum, 26. Our median was, what was our median again? Oh, yeah. Way up here, 21. The lower quartile was 8. Now, here's an interesting one. Do you remember that our upper quartile was also 26? So, what happens then? Well, all we do is complete our box and whiskers. That means that we put on the top of our box, the bottom of our box, and our left whisker, because we don't have a right whisker over here. It's sitting right on the top. We've already seen that our data is clumping up here around that 26, which is the maximum. So those kids who know 26 uppercase letters have gone on to learn their lowercase letters, and then they're starting on their sounds. So they can't learn anymore. They've topped out on capital letters, but that's okay. We're still interested in all these other kids down here who still have a ways to go. So it is possible not to have a whisker. So when your upper quartile and your maximum are the same, that means you don't have a whisker. It could be the same down here. We could have them all. Maybe we had a class where half the kids didn't know any letters coming in. Maybe they would all be clumped around 0 or 5 or 10 or something. So it is possible to be missing a whisker. And that's what it looks like. So this is talking about, again, we're back to that same idea of symmetry and skewing. So if our whiskers were approximately the same length, we would think about our distribution as being symmetric. But if the right whisker is longer than the left whisker, which it is not, our data would be positively skewed. Remember that ball of string where we'd be pulling the data to the positive? Actually, our left whisker is longer than the right, so we're pulling our data this way. Our distribution is negatively skewed. Look at this. Our median is here. We have 50% of our kids are within 5 letters. They know between 21 and 26 letters. 50% of our kids know fewer than 21 letters. So that makes sense. Our data is spread out much more in the bottom half, and they're doing exactly what we hoped, which is clumping up there in the top. They're learning more and more students know more and more letters. That's good. Okay, let's look at the next one. So here we're comparing these two data sets. So this is what it looks like. We frequently put box and whisker plots on the same scale so that we compare the data. So just looking at this, what comparisons can you make? Talisha, do you have any thoughts?
No.
Okay.
No, but I haven't seen these since like middle school. Oh gosh.
That's okay. Good. then here's like, look at the median of the August data. How does that compare to the median of the October data?
How does that compare?
Yep. So
Um,
another way of asking is median greater than the October data?
you said is the median greater?
Uh-huh.
Um,
Or
well,
less.
they're both lined up with each other.
This is the median for the August data, and this is the median for the October data.
Okay. That what comparison can I make? The median is lesser.
The
Is
August
lesser than the October data for August.
is less than the August median is less than the October median. So remember, half of the students use 8 or more letters in August, and in October, half of the students use 1 or more letters. So that's good, right? Because we want more and more students to know more and more letters.
Okay.
Is the minimum. Remember in August, we had students who knew 0 letters. And in October, everybody knows at least 3. So that's good. Our minimum is greater than October. And notice our maximum. It's the same, but we can explain that because you can only know 26 letters. There are only 26 to know. So our upper quartile is greater than on October. Our median is greater in October. Lower quartile is greater in October. And our minimum is greater. So because what we want is for our students to be learning more and more letters. We have one more data set. This is September. First thing you do is place an order to least to greatest. Median of the set. So our minimum is 6. Our maximum is 26. Our median is 25. So, ooh, that looks good already. And then we have to find the lower quartile and the upper quartile. So remember, we start by dividing our data sets in half from using the median of the entire data set. And then we find the median of the lower half. And again, we have to find the median of 8 numbers. So we're going to take the average of these 2 numbers, the 2 middle numbers, 17 plus 20, then divide that by 2. So our lower quartile is 18.5, and that makes sense because 18.5 is right in the middle between 17 and 20. So good. Our arithmetic checks out. Now look up here. Our upper quartile is all 26s. So that makes it easy. Our upper quartile is 26. That wasn't hard. So now we take those, our 5 numbers that we have, our 5-number summary, minimum, lower quartile, median, upper quartile, maximum, and we plot them on the number line. So our minimum was 6, our maximum was 26. Our upper quartile is 25, No, that's our median. Excuse me. Our median is 25. Our lower quartile should have been 18 and a half. That's in the wrong place. And our upper quartile was 26. So I'm actually going to fix this so that we can see. Well, wait a minute. I wonder if I fixed it on the next slide. Complete the, oh no, this is the next slide. I want to get out of here and see if I can fix it. I need you to move over here.
If you hit escape, that should get you out of full screen mode.
Yeah, I always get confused on that. So wait a minute, where are we? We're here. This should be not that one. Not that one. It's going to be right. Oh goodness, there. 18 and a half. Come on, you. So this is what I have to go through to make all these. Seriously. Yeah. Not easy. That's why they look a little skew with. We're just about getting to the ones I made with Desmos, which I like better. Okay, good. I'm happy to have fixed that. Okay. We're plotting it again. Let's go in the right place. We complete our box on Whiskers. Whoa, look at that. So here's 50% of our students are all up here but at 25 or higher. 50% are at 25 and lower. So what can we say? Which direction is our data skewed, Tylisha? Do you remember the ball of string? And we're pulling this data down. So we can say that our data is skewed or is negatively skewed because we've stretched it out and pulled it out all the way down there. Let me go back. Okay. And we can see that our data is very spread out from here to here. 25% of our students know between 6 and 18 letters. 25% know between 8 and 25 letters, or 18 and 25 letters. 25% know between 25 and 26, and all the way up here, 26. So this is really good. By December, half of our students know all of their letters. So now we can compare all three data sets. So what can you tell us about the medians of these three data sets? Here it is in August. Here it is in October. Here it is in December. So each time, what's happening to it, Tylisha?
It increases, the median goes up.
Yep. And what about our lower quartile?
It increases too.
Yep. And our upper quartile from here to here, now that's the same from October to December. Do you know why it stayed the same? Because what number is it?
6. So the median stays 26.
The upper quartile stayed at 26.
Okay.
That's the most numbers you can know. Okay. So can you see where our data started off being positively skewed, meaning that more of our students were clumped down here, knowing fewer letters, and now just what we wanted, our data is negatively skewed, And we can see that most of our students know or half of our students know all of their letters. So our data has shifted in the direction that we want it to shift. Let's look. This is the beautiful box plots you can make on Desmos. They turn out a little bit nicer than the ones that I made. So you can see they look the same. You can see that here's our data where in August we have some people down at 0 and we have some all the way up at 26. We can see that our median increases with each data set. We can see that our lower quartile increases with each data set. We see that it's in August, at the beginning of the school year, our data is skewed positively or skewed to the right. So more of our students knew fewer letters. And in December, it's skewed to the left because most of our students know most of their letters. Now, here's another piece of data that is sometimes referred to in the when we're talking about box and whisker plots. And it says, what comparisons can you make about the spread of the data of the 3 sets? And one thing we talk about is the interquartile range. So when we say inter, that means between, and then between the quartiles. So remember, this is our lower quartile, this is our upper quartile. So it's asking us, what is the range from the lower quartile to the upper quartile? Just looking at it, it looks like October and August are about the same, but December is much smaller. The range of my inner quartile here between the upper and lower is much smaller. Well, how do we know? Here's how you compute the inner quartile range. It's the difference between the lower quartile and the upper quartile. So it's telling me how spread out the middle 50% of the data are. So let's go back and look at that again. It's the difference between the lower and the upper quartile. So when we say difference, we know that we're talking about subtraction. Difference is one of the words that lets me, that tells me, cues me in to think about subtracting. So how do I figure out the inner quartile range? I start with my upper quartile and I subtract my lower quartile. So if we go back and look at the numbers, in August, we would see that our upper quartile was 18 and our lower quartile is 1.5. When I do that subtraction, I get 16.5. In October, upper quartile minus lower quartile. My upper quartile was 26. Remember, it was sitting right there on the maximum. And then my lower quartile was 8. So 26 minus 8 is 18. So we were correct. We said that the interquartile range between August and October was about the same. And the fact that it's a little bit larger in October might be because we had 2 more students. It might be because that's the point where after a couple of months, some students are beginning to get it and some are still just trying to figure out where the crayons are. So, you know, there's a spread there that happens in October. And then in December, our upper quartile was still 26 and our lower quartile is 18.5. So our inner quartile range is 7.5. So range is a term that tells us to look for how spread out the data are. And all of this falls in the category of data analysis, Tylisha. So when we're looking at, when you say this isn't exactly like the math that you were thinking about, it's because we're examining what the data tell us and what can we understand. And one of the key things that statisticians look at is how clumped together our data is and how spread out it is. And that can give us a lot of information about a particular situation. And it depends on what the situation is. In August, we're okay with the big spread. But by December, we're hoping that our spread has closed down because we're hoping that our students have responded well to our teaching and are learning those letters that they need to learn. So what we would expect there in December to be a big spread in is letter sounds, because some students haven't started really learning too many letter sounds. They're still trying to figure out what the letters are. Other students came in knowing all their letters, and so yes, they moved on quickly to learning their letter sounds, and now they're over here learning sounds, and so our data is going to be very spread out again. So based on this data, Tylisha, here's the big question. What can you say about teacher and or student performance? And this is why we go through all this hassle, is because we're trying to see what we can say about student and teacher performance. So looking at this, if you were a parent of a child, what could you say? How would you interpret this data?
I would say that that the children improves in knowing the letters instead of going down. It increases, the data's increasing.
Good. And you were very wise in what you said, because you did not say that it tells you a lot about teacher performance, because really truly it doesn't. You said exactly what you can see, which is the students improved in knowing their letters. We don't know whether that was because the teacher was awesome, or maybe the teacher did nothing and all these kids have wonderful parents who teach them. Or maybe this is fabulous when we compare it to other students in other classes. Or maybe this is terrible. Maybe in every other kindergarten in the United States, all the children know all of their letters by October. So all we can say, you did a great job of not saying more than what the data tell us. What the data tell us is that the children in this class improved in knowing their letters. The other thing we don't know is how any individual student did. We don't even know if those 3 students who didn't know any letters in August improved, because for all we know, those students moved out of town and went to some other school, and we replaced them with 3 students who knew all of their letters in October. So this doesn't tell us really about any one individual student's performance. It doesn't really tell us about how the teacher did or what kind of students the teacher has in the class. But let's say that this data right here was one teacher in December, and this data was another teacher in December, And this data was another teacher in December. So these were, instead of being August, October, December, these were all in December, but this is class 1, class 2, class 3. We would sure be taking a look to see what this teacher was doing in his or her class, and what this teacher was doing and what this teacher was doing, to see if there was a difference, if there was something that this teacher was doing that was so much better in tune with what the students needed than this teacher. Or maybe this teacher is the one that everybody they keep moving kids in and out of her class, and she keeps starting all over again with her kids. And, you know, you just don't know. So this would give you an example of something to look at. So good job you for not over interpreting the data. So
Thank you.
that's what we have about box and whisker plots. There is another video. I don't know, Chris, is that first one available to look at?
It will be up by the end of the week.
Okay, so there's another one that you can look at that's kind of an intro. So to remind you of all of the different pieces and how they're put together. But that is the basic idea behind box and whisker plots. So I hope you feel a little bit more comfortable with them now than you did when you started.